The Signature tab contains three modules. The first one is the Compare Signatures module. This module is used to perform intersection analysis and compare pairwise contrast with each other in order to identify similar profiles and also find genes that are commonly up or down regulated between two or more contrasts. There is a box on the left hand side from which you can select the contrasts from a list, and in the options menu you can select whether to perform the analysis on all the genes or just a specific gene family. You can also select at which level you want to perform the analysis, whether at the gene or the gene set level. Now in the Pairs tab, the platform first of all displays a series of pairwise scatter plots that compare your contrasts with each other and calculate a correlation. So you can see here whether pairwise contrasts are related to each other or not via the R value. So in this case you can see this one is pretty low, so there is no correlation, whereas this one has a high positive correlation. These plots are interactive, so if you scroll on them you can see information on individual genes. And you can also select an area from one of the plots which will highlight the same genes across all the plots, and will also change the cumulative fold change plot here. Now you have to be careful, because to revert back to the default cumulative fold change plot you need to click twice on the plot here in order to revert everything back to default. There is a Venn diagram that shows the intersection between the various pairwise comparisons. You can customize it here by altering the FDR and log fold change thresholds, and you can also decide whether you want to display up and down regulated genes as separate numbers or just as a single number. And finally, at the bottom we have the cumulative fold change plot, which I mentioned before. And on this plot, if you select a specific overlap regions, let's say for example the regions that is overlapping in all three groups, so A, B and C, which corresponds to this region, then you get a list of you get a plot that shows the cumulative fold change, and you can download this as a PDF, a PNG, or you can download it as a CSV file that shows all the genes within this region. You can also change the settings by showing the absolute fold change or leaving a relative fold change instead. Next, we have the Test Signatures module. Under this module, you can test your own gene signature against the pairwise contrasts available from the dataset. So in this box, you can paste your custom generated gene signature, or you can select one of the three available examples. And from the options menu, you can furthermore select from KEGG or Hallmark gene sets, or even select one of the contrasts themselves as your signature. In the Enrichment tab, you will see enrichment plots of your gene signature against all the available pairwise contrasts. Next, in the Overlap and Similarity tab, you see the gene sets from public databases that are most correlated to your signature gene set. So in this case, because I picked up apoptosis, you can see that growth terms associated with the regulation of the apoptotic pathway show a very high score. And here in the table below, you see a list of all the gene sets from public databases that have been found to be correlated with your signature gene set. Under the Markers tab, the platform generates markers TSNE plots using the expression of the genes from your signature gene set in the samples available in your dataset. So you can see for each one of them how the expression of these genes changes in the pairwise comparisons. On the right hand side, the platform also generates an enrichment table that shows you the normalized enrichment scores for all the pairwise contrasts, and underneath it, it produces a table that shows the genes in the query signature sorted by fold changes corresponding to the contrast selected here. And you can select multiple contrasts as I do here, and then you will get your scores for the contrasts that you selected. Finally, on the right hand side, the platform produces first of all an enrichment table that shows you the normalized enrichment scores for each one of the contrasts that you have available in your dataset. And underneath this, it shows you a list of the genes from your query dataset and the changes in expression in the selected contrast. You can select multiple contrasts as I'm doing here, and then you will get in the table the changes for each one of the contrasts that you selected. The last module in the signature tab is the Find Biomarkers module. This module is used to select biomarkers that can be used for the classification of your samples or for prediction purposes. Furthermore, if you have included patient survival data in your original input, it will be used here. On the left hand side, there are two scroll down menus. In the first menu, you can select the phenotype you want to look at, and in the second scroll down menu, you can select whether you want to perform the analysis on all the genes or a specific gene family. The platform produces four main plots. The first plot shows you the cumulative importance score for each of the genes that have been selected as biomarkers by 6 different machine learning algorithms. Next, there is a heat map that shows you the expression of the potential biomarker genes in the phenotypes from your data. In this case, I only have 2 phenotypes, untreated and treated, and you can see that there is a clear difference in the expression levels. The platform also produces a decision tree. Now, this decision tree generally changes each time you do a different computation. So I suggest you repeat this several times before you settle down to a decision tree you want to discuss or present. In this case, my dataset has produced a decision tree that uses a heat shock protein A6 as a biomarker to distinguish between untreated and treated samples. And underneath it, the platform also produces box plots for the 8 most significant markers, and you can see here that the box plot for heat shock protein A6 shows a clear distinction in gene expression between the untreated and treated samples.